everyone. In this session, we will be starting one of the classical problem of process synchronization, that is known as what producer-consumer problem. So we will see each and every point related to producer-consumer problem from very basic to the advanced level. Okay, understand clearly? So I am going to start producer-consumer problem here. Producer-consumer problem here. Producer-consumer problem in detail. Okay, producer-consumer problem. Okay, so why it is known as what producer-consumer problem? Because there are one producer which can produce the item, and there are one consumer which can consume the item. Okay, so here both producer and consumer both are using a buffer, and the buffer size is fixed, means both are using what? Bounded buffer. Okay, both are using what, my dear friends? Bounded buffer, because buffer size is fixed. Okay, so that's why this producer consumer problem is also known as what, my dear friends? Bounded buffer problem. Please note it down. Bounded buffer problem. I will give you each and every point. Bounded buffer problem, because producer and consumer are using here bounded buffer, fixed size buffer. Okay, fixed size buffer. So that's why it is also known as what? Bounded buffer problem. Bounded buffer problem. So as I told you, my dear friends, note down the first point. This is one of classical problem of process synchronization. We have more classical problems, okay, of process synchronization, but this is one of classical problem of process synchronization. Process synchronization. Okay, process synchronization. So here both my dear friends, producer and consumer are using. First I am going to give you all the basic points, then we will take code, okay, for the producer and for the consumer, and we will see the execution of producer and consumer code. Okay, so here both producer and consumer are using what, my dear friends? As I told you what? Buffer, fixed size buffer. Okay, suppose here I am taking what? Buffer size is what, my dear friends? Buffer size is what? 8. This is what? Buffer size. Okay, this is what? Buffer. Okay, this is what? Buffer, and buffer size is what? Fixed, 8. Okay, so how we will provide the indexing to the buffer? So we will provide the index to the buffer like this: 0 to n minus 1, 0 to n minus 1. So here we are assuming buffer size is what, my dear friends? 8. So indexes of the buffer is what? 0 to 7. Okay, like this: 0, 1, 2, 3, 4, 5, 6 and 7. Okay, like this. Okay, so here in producer consumer problem we need to use 3 variables: in, out and count. Okay, in, out and count. Okay, so count variable, here count variable is what? Shareable variable. Okay, means count variable is used by both producer and consumer to know how many items are present at any time in the buffer. Okay, how many items are present at any time in the buffer? To know that, producer and consumer both will use the count variable. Okay, so here is a count variable. Here is a count variable, my dear friends. Here is a count variable. Okay, here is a count variable, and I will give you this is what, my dear friends? Shareable variable, means share by both producer and consumer, both share this count variable to know how many items are present in the buffer at a particular time. Okay, and as I told you, we are using here 3 variables: in, out and count. Okay, so there is a in variable, my dear friends. There is a in variable. Okay, there is a in variable. Okay, so in variable is used by the producer. Okay, in variable is used by the producer, okay, to used by the producer, okay, means at which place it can produce the item in the buffer, at which place, okay, in variable will used by the producer to identify where it can produce the next item, where it can produce the next item, okay. So this invariable is used by the producer, this invariable is used by the producer, my dear friends, to know to know the slot in buffer where it can produce item, where it can produce item, okay. And there is one more variable, that is what, my dear friends, out, that is out, that is out. So out variable is used by, my dear friends, consumer, out variable is used by consumer, okay, to know where it can consume the item, to know the slot where it can consume the item in the buffer, from the buffer, from which slot it can consume the item. So out is used by, my dear friends, as I told you, consumer, out variable is used by consumer to know from which slot in buffer it can consume what, it can consume item, okay. So I hope you understand, and these are the basics related to the producer consumer problem, okay. These are basic related to the producer consumer problem, my dear friends, okay. So there are two global shared resources by consumer and producer are buffer and count, means buffer is used by both the processes, producer and consumer, and count also used by both the processor, producer and consumer. So these are the global shared variables, okay. There are two global shared variables, that is what, buffer and count, means buffer and count used by both the processes, producer and consumer. I hope you understand clearly, okay. So count is used, count variable, it is used by both processes, producer and consumer, to identify how much items, how many items are present, in buffer at a particular point, okay, at a particular point. I hope you noted down all this, okay. I hope you noted down all this. First listen me carefully, then I will give you the time to note down, my dear friends, okay. So I want to tell more basics related to producer consumer problem, then we will take the code of producer and consumer and we will execute, okay, one by one. Understand clearly? So next thing is what, my dear friends? Next thing is what? Please note it down. Next thing is what, my dear friends? There are two global shared variables, that is what, count and buffer, because count and buffer is used by producer and consumer, both the processes. There are two global shared variables, okay, means used by both processes, processes, producer and consumer, and what are the name of those global variables, my dear friends? As I told you, one is count, and second one is what, my dear friends, buffer. Second one is what, my dear friends? Buffer. Here these are buffer is not a variable. You can say what, resources. There are two global shared resources, not variables. Okay, because buffer is not a variable, it is a resource. Shared, global shared resources. Global shared resources. Okay, I hope understand. Okay, so I want to give you one more point, my dear friends. One more point. Please note it. Please note it. Okay. Whenever we want to provide a synchronization between consumer and producer, then there are two conditions. Okay, if we want to, whenever we want to provide the synchronization between consumer and producer, there are two conditions. Okay, so please note down this point also. Whenever we want to provide synchronization between producer and consumer, between producer and consumer, then there are two conditions. Then there are two conditions. And what are these two conditions? What are these two conditions, my dear friends? Okay, what are these two conditions? The first condition is what, my dear friends? The first condition is what? When the buffer is full, the producer is not allowed to produce the item in buffer. Okay, when the buffer is full, then how? Because here we are using what? Bounded buffer, limited size buffer. Then when buffer is full, then how producer can produce the item? Okay, so this is the first condition. When buffer is full, when buffer is full, when buffer is what, my dear friends, full, the producer is not allowed, the producer is not allowed to produce items in the buffer, because buffer is full, and here we are using limited size buffer. When buffer is full, then how it can produce the item? Okay, and the second thing is what, my dear friends? Second condition is what? When the buffer is empty. Okay, when the buffer is empty, means there is no item is present in the buffer. Okay, then consumer is not allowed to consume the item from the buffer. Okay, very simple. These are two conditions. If you want to provide synchronization between producer and consumer processes, then these are the two conditions. Okay, when buffer is empty, I will show you. Okay, the condition when buffer is empty through the code. When buffer is empty, first I am giving you all the points. When buffer is empty, then consumer is not allowed to consume the items from buffer, because buffer is empty, because buffer is what, my dear friends? Because buffer is empty. So these are the some basic points related to the buffer. Okay, related to the producer consumer problem, classical producer consumer problem. Now I am going to take the codes of the producer, means how producer can produce the item into the buffer, and how consumer can consume the item from the buffer. Okay, understand clearly? So please note it down, these points. So I hope you noted down, my dear friends. I hope you noted down. So here this is a code for the producer. Okay, now this way producer can produce the item into the buffer, and this is a code for the consumer process. Okay, consumer process. From this code, consumer can consume the item from the buffer. Okay, so as I told you, my dear friends, they both will share a buffer. They both will share a buffer, because buffer is a shared resource. Okay, so they both will share a buffer. Okay, and Here we are using buffer size is what, my dear friends? 8. So index will be what? 0 to 7. Index of buffer is what? 0 to 7. 0, 1, 2, 3, 4, 5, 6 and 7. Okay, understand clearly? And here we have a count variable, and here we have a, my dear friends, is what count variable. So initially buffer is empty. Initially buffer is empty, my dear friends. So initially buffer is empty means no item is present. No item is present in the buffer. So count variable value is what, my dear friends? 0. Initially when buffer is empty. When buffer is empty. And there is what, my dear friends? There is a invariable. There is a invariable and there is a out variable. Okay. There is a out variable, my dear friends. So invariable is used by the producer to know the empty slot, to produce the item, and out variable is used by the consumer, as I told you. Out variable is used by the consumer to know the slot from where it can consume the item. Okay, it can consume the item from the buffer. So this is, my dear friends, buffer. This is what? Buffer. This is what? Buffer. Okay. So I hope you understand clearly. So when buffer is empty, then I am going to discuss the case 1. My dear friends, listen me carefully. Case 1 means when buffer is empty, then producer can produce the item. Okay. Then and if producer want to produce any item, then it will execute this code. My dear friends. Suppose producer can produce the item X. Suppose producer want to produce the item X1. You can. Okay, item X1. Then it will execute this code. Okay. Integer item P means X1. While true, this is always true. Produce item P. Produce item P. Okay. Produce item P. Okay. So initially this invariable, okay, where producer can produce the item at 0 slot. So initially this in a variable value is what? 0, because producer can, initially buffer is empty, so producer can produce the item at slot 0 in the buffer. Okay, at slot 0 in the buffer. Okay, so producer will produce the item X1 here. Okay, while count equal to n. Okay, while count equal to n. Okay, while here not need to put here. Okay, so while count equal to n, so produce item P. So producer will produce item P. Item is what? X1. So it will check the buffer first. Okay, while count equal to n, here n equal to what? 8. So while count equal to n, when all the slots of the buffer is full, okay, then how producer can produce the item? As I told you, when buffer is full, then producer is not able to produce the more items. Okay, so this is a buffer full condition, my dear friends. This is a buffer full condition. Okay, so when buffer is full, then producer is not able to produce the item in the buffer. Okay, it will stuck into the loop. Okay, if buffer is empty, then go to further. Okay, buffer in equal to item P. Okay, buffer in equal to item P. So in 0 location, we will produce this item X1. In equal to in plus 1. The next empty slot, then in is what? In is used to give the producer the next empty slot, means where it can produce the item. So now in equal to in plus 1 mod n. Okay, in equal to in plus mod n. So in is what? Initially 0 plus 1 mod n. Buffer size is what? 8. So 1 mod 8. So what you will get, my dear friends? 1. So need to replace this in variable from 0 to 1. 0 to 1 means if producer want to produce next item, then empty slot is what? 1. Means at one slot producer can produce the another item. Okay, so like this, listen me carefully. Okay, so now this need to execute this next instruction. Count equal to count plus 1. Count equal to what? Count plus 1. Okay, initially count is what? 0. Initially count is what? 0. Now in the buffer we have one variable, so we need to increment. Okay, now count equal to what? Count plus 1. So to execute this instruction in assembly language, we need to execute these 3 instructions. I hope you understand. So first instruction is what? RP. We will use a register, producer register RP, in which we will put what? M count. And what initially we have in M count? 0. What initially we have in N count is what, my dear friend? 0. So I hope you understand. I am going to explain here. So in the first instruction, whatever we have in N count, we have 0. So we need to put this into producer register. Okay, so 0. Increment in the second instruction, increment RP, means we need to perform this instruction RP plus 1, RP plus 1, RP plus 1. So what will in the RP now? 1. Okay, and in the third instruction, store M count comma RP, means whatever we have in the RP need to store in the M count. Need to store in the M count. Okay, in the third instruction. So count value will become from 0 to 1. Okay, count value change from 0 to 1. Okay, now this way, or now this way. So producer is able to produce the item in the slot 0. Now suppose if producer want to produce another item, what? X2. Another item X2, then it can produce. Okay, from where it will identify at which slot it can produce the item in the buffer. From the in variable. So in variable is what? 1. In variable value is what? 1. So producer can place this X2 at 1. Okay, so it need to execute this code again. Okay, so when it will place this X2 here, then again is what? Buffer in equal to item P, n equal to in plus 1 mod n. Okay, so now in is what, my dear friends? Is 1 plus 1. Okay, 1 plus 1 mod 8. So what? 2 mod 8 equal to what? 2. Now in equal to in plus 1 mod n. So it will become from 1 to 2. It will become change from 1 to 2. Okay, now again execute this count equal to count plus 1. Okay, so at present we have in the count is what? 1. So this one we will put into the RP. Okay, and RP increment. Now in the second instruction need to increment. So like this way. Okay, so in RP we have, in count we have what? 1. So we will put this 1 M count value into the producer register RP. So need in the second instruction need to increment RP. So here RP value is 1. 1 plus 1 how much? In 2. In RP we have 2. We need to store this RP into count. So this will become change from 1 to 2 like this. This is the case first. Okay, understand clearly? Understand clearly, my dear friends? So here this out variable initially have slot initially have value 0. Okay, initially have value 0. Okay, so now consumer comes, producer produces 2 items X1 and S2. Now consumer, and if producer want to produce more item, then at which slot it can produce the item? At slot 2 in the buffer. Okay, because slot 2 is empty. Okay, now suppose consumer comes and it want to consume the process. From the buffer. So it will execute this code. Okay, it will execute this code. Integer item C, means it want to consume any item C. While true, this condition always true. While count equal to 0. While count equal to 0 means when buffer is empty, count is used to identify how many items are in the buffer. So while count equal to 0, then consumer is not able to consume the process from the buffer. It will stuck here. It will stuck here in the loop. Okay, it will stuck here in the loop. So this condition is what, my dear friends, to check buffer is empty. This condition will show is what? Buffer is empty. Buffer is empty. Buffer is empty. Okay. If buffer is not empty, item C equal to buffer out. Item C means which item is it can consume from the buffer. So here we have what? Zero slot. Okay. Means we can consume zero slot item from the buffer. So out equal to out plus 1 mod n. So now we need to change this value of out. Okay. So out equal to out plus 1. So out equal to out plus 1 means that out is what? 0. 0 plus 1. 0 plus 1 mod 8. So 1 mod 8. So what is 1? Okay. So now this out value change from 0 to 1. 0 to 1 means if consumer want to consume more items, next item, then at which slot it can consume the item from the buffer, from the slot 1. Okay, from the slot 1. Okay. So as I told you, out is used by the consumer to identify from which slot it can consume the item from the buffer, okay. So now need to execute this count equal to count minus 1, count equal to count minus 1. Okay. So here it consumes what? X1. Here it consumes what? X1. Okay. Because at slot 0 we have X1. Okay. So we need to execute this count equal to count minus 1. Okay. So to execute this instruction in assembly language, we need to execute these three instructions. Okay. Load RC comma M count. Load RC comma M count. Okay. Whatever we have in the end count now, we need to put that into RC, means consumer register. Okay. Like this. So what we have in count. Okay. When what? When consumer is consuming the item 2. So we need to store into RC. Okay. Then decrement RC, we need to decrement RC minus 1. So what? 2 minus 1 is what? 1. We need to put this 1 into RC. Okay. And again in the third instruction, store M count comma RC. Whatever we have in the RC, we need to store in M count. So how many items now? When one item is consumed by the consumer, then how many items we have in the buffer now? 1. Okay. So now this way, process item C. Okay. Understand clearly? Understand clearly? So now we have how many process in the buffer? Only 1, and count is also showing 1. Okay. So this is the case 1. This is the case 1. Now this way, producer can produce the items and consumer can consume the items. Okay. So what is the problem in this producer consumer process? What is the problem? Okay. What is the problem? Okay. So I am going to take here case 2. So if you want to note it down, guys, I explained everything in detailed way. So please note it down in your own language. Okay. So please note it down carefully. Please note it down carefully. To execute this count plus 1, we need to execute these three instructions. Okay. I hope you understand. To execute this count equal to count minus 1, we need to execute these three instructions. Okay. I hope you understand clearly. So please note it down this. Then I will give you the case 2. Means what is the problem in this producer consumer problem? So my dear friends, as I told you, if you are able to execute the codes, whatever given in the question, then you are able to solve each and every question of process synchronization. Don't worry. First, listen the explanation carefully. Then after need to note down. Okay. I will give you time to note down. Don't worry. So I hope you noted down, my dear friends. Now I am going to explain the case second. Okay. Here I am going to explain the case second. Okay. So I am raising all this. Okay. I am raising case first from here, and I am going to explain case second. Okay. So I am raising all this. Okay. Okay. So let us consider a situation. Let us consider a situation in the buffer. In the buffer we have three items. Let us consider a situation in the buffer. We have three items, x1, x2 and x3. Then what will be the count value? Count value will give you how many items are present in the buffer at any time. So at this time, how many variables, how many items are present in the buffer? 3. So here what will come, my dear friends? 3 will come. Okay. And in variable is used by the producer. Okay, to tell the producer at which place, at which slot you producer can produce the problem, sorry, producer can produce the items in the buffer. So at which, what is the next empty slot where producer can produce the item? 3. So here what will come? 3. Okay. And from where, consumer can consume the item from the buffer? From 0. From 0. Okay, from 0. Just listen me carefully. Case second. Just listen me carefully. Case second. Case second. Case second. Okay. Suppose, case second. Suppose producer comes. Suppose producer comes here and try to produce the items in the buffer and need to execute this code. So when it will execute this code, listen me carefully. Suppose producer comes. This is a flow. Okay. Producer came and it execute the instruction first, and it execute the what, my dear friends? Instruction first. Instruction first is what, my dear friends? In equal to in plus 1 mode n. Currently in value is what? 3. Okay. So 3 plus 1 mode n. Okay. 3 plus 1 mode n. Okay. 3 plus 1 mode n. Okay. So sorry, this is not. Here it will come. Here it will come. So it will execute the instruction first. Okay. So whatever in the count, it will put into the RP. Whatever it will have into the count, it will put into the RP. Okay. It will put into the RP, my dear friends. Okay. Suppose producer comes, okay, and it, when it will execute the instruction first, then whatever we have in the count, it will put into the RP. So in RP, what will go, my dear friends? Register, producer register, what will go? Count value is 3. 3 will go. Next, it will execute the instruction second also. Then it need to increment this RP. So what it will put into RP? RP plus 1, 3 plus 1 is what? 4. Okay. And after executing these two instructions, suppose producer prints and consumer came. Consumer came here, and consumer also executes these two instructions, first and second. So when consumer will execute the instruction first, when consumer here producer what prints? Here producer what prints? Producer prints here, and consumer came. Consumer execute this instruction I1. Okay. So load whatever we have in n count, load into RC. Load into RC, my dear friends. Load into what? RC. Okay. So what we have in the m count? 3. Okay. Before updation, producer what prints? Consumer came. Consumer execute this instruction 1. So both are sharing a common variable count. So whatever we have in m count need to store in the consumer register. Okay. Consumer register. This is the previous situation. Okay. So what we have in the m count? So what will go in the consumer register is what? 3. Decrement RC. Okay. Decrement is RC. So what we need to do? 3 minus 1 is what? 2. Okay. So when consumer also execute the instruction second, it also prints. It also prints, my dear friends. Suppose it also prints. It also prints from here. It also prints from here, my dear friends. It also prints from here. It also prints from here, and suppose it want to produce an item 4. Okay. It wants to produce an item 4. So it will put here and it prints before updation. Before updation it prints. Okay. So understand clearly. And I2 also prints before updation, and it consumes from where? Out value is what? 0. Suppose it consumes from here x1, but before updation this out it prints. Before updation this out it prints. Okay. Before updation this count it prints. Before updation this count it prints. Okay. So now the value of this 3 will become what, my dear friends? 4. And now this value of 0 will become is what? 1. It prints just because of the updation, just before of the updation of count, but int is updated from here, and out is also updated from here, because we are executing these instructions. I hope you understand clearly. Okay, I hope you understand clearly. Okay, so now producer comes into picture again. Producer what? Resumes. Producer resumes. Okay, producer resumes here. So it already executed 2 instructions. So it will resume from the instruction third, instruction third, instruction third. Okay. So what we have in the RP 4. So it will put through the instruction third into the count. So it will replace this 3 by 4. Okay. So producer updated this count value. Now again suppose consumer comes. Now again suppose consumer comes here. Understand, consumer comes here and it already executed 2 instruction. So it will resume from the third instruction. So what we have in the RC we have 2. We will put this into M count. So it will replace this final value of count by 2. Okay. So consumer came and it executes the instruction third, because it already executed instruction 1 and 2. Okay. So here we have what? Inconsistency. Here we have what, my dear friend? This is a problem. Here we have inconsistency. Okay, because count variable value is what? 2. Means according to this, in the buffer how many items? Okay, we need to have only 2, but here how many items in the buffer? 1 2 3. Okay, so this is a inconsistency problem. So this problem arises in the producer consumer problem, my dear friends. I hope you understand. So this is a producer consumer problem. Okay, this is a universal assumption, my dear friends. I hope you understand clearly. Okay, I hope you understand clearly. So please note it down first, then I will give you the next point, my dear friends. So this is the case second. Okay, there is a inconsistency. Okay, between the producer and consumer. Means producer and consumers are not synchronized there. So this is a producer consumer problem. I hope you understand clearly, guys. So I hope you noted down, my dear friends. Oh, okay. So just because of this, there is a, please note it down, there is a inconsistency between producer and consumer. Producer and consumer means they are producing what? Inconsistent result. Producer and consumer means producing inconsistent result. Okay, inconsistent result of count. variable. I hope understand clearly. Okay. So after this, we will see the solution of producer consumer problem. Okay, through the semaphore. Okay. So I hope you understand clearly. So please note it down this point also, guys. So I hope you noted down, my dear friends. Okay.